everyone. My name is Benjamin. I'm assistant professor at the department. I started last summer 2020, and it's been a year now. And I'm within the electromagnetics and optics track in the department. The focus of my research is primarily low frequency electrostatics, and we leverage these to develop new biomedical devices that we use to monitor and measure health. So rather than walking you through a presentation, I thought I would just walk you by my lab website that contains the most updated information regarding the research projects and people involved in the lab. So as I mentioned, this is our building, the Sorenson Molecular Biotechnology building, and what you see behind are the Wasatch Mountains, which are really nearby. And this side here, these buildings over there, this is the medical campus where we have close collaborations for several of the projects that we are currently developing. So just to talk about a few research projects that are currently happening in my lab. Actually, this one is what it's going to have me to step down from the meeting within a few minutes, because we need to discuss these results with the company that is sponsoring this research. So we have a project funded where we are doing some ultra-realistic human model computer simulations to determine the safety of applying electrical current through the body for patients that have implantable cardiac pacemakers, as you can see here. And another project that is very exciting, and we have a manuscript under review, involves the measurement of mental stress on people as they are developing, they are in a virtual reality environment, and we induce fear in people by make them believe that they are walking through a plank in a high heights. And so there is a lot of software coding here, and this is the size of a credit card, and we measure the ECG signal, and out of the ECG signal we can process online and obtain heart rate variability, all these meaningful physiological metrics that can be used to quantify the mental stress that a person might have. And all of this is connected to an IoT server and so on and so forth. There is another project that we are now starting, which involves using ultrasound imaging to evaluate the structure and content of skeletal muscle, and specifically the tongue, which gets affected in patients that have some type of neurological conditions. And I guess one of our latest actually inventions is what we call the Utah depressor, which stands for user tongue array. And this basically, it looks like a popsicle, like the one that they put you in your mouth when they want to see the back of your throat. But this one instead has sensors where we apply electrical current and measure voltage. And so the Utah depressor connects to the user tongue electronic system, or UTS. And we have actually funding from an association to evaluate the accuracy of this device in population here in Salt Lake City that have a specific genetic disorder that affects the condition of their muscles. So really quickly, students in my lab are Shusong, who is a visiting PhD student who has done tremendous job. Then Jiabao and Henry that joined over last summer are both graduate students, and Elena and Ye, who are undergrads that are also involved in some of the research activities. And these are some of the previous alumni that joined the lab a few years ago, even before I started at BU. So if you are more interested in details regarding publications and the kind of research we're doing in my lab, please go to the publications tab. You'll see that this year we have published, I believe, something like 15 journal papers in medical and engineering journals, and they are all available to download in case you are more interested. And some exciting news that John was mentioning at the very beginning is that actually the local TV news pick up on a story of a paper that we just published, where we have partnered with a company to develop a new technology to diagnose breast cancer in women. And so this is actually very interesting because it provides an alternative to the clinical standard. And there are videos where you can see how the technology works and some other, related news and information on the lab. You can go to the Twitter account for the lab where we have also more information. So to give you an idea about the kind of funding that we have been funded by NIH, the Massachusetts Technology Transfer Center, Friends of FSHD for the Tongue Project, Maxim Integrated, which now it's analog devices. It's also funding our lab, as well as Impediment and BSecure. And we have strong collaborations with our partners that are, Texas Instruments and all these other companies that develop either products for clinical research or consumer electronics. And if you have questions or you would like to know more information as to whether you will be a potential candidate for the lab, please don't hesitate to contact me. You can either use this form or send me an email, and I'll try to get back at you as soon as possible.